today we're starting with study unit 8, and that is around point estimates and confidence intervals. So basically what we've done in study unit 7 was we looked at the mean of your proportion, and your mean of your sample mean. So and now what we're going into nearly as the next level to, and let me put nearly, I want to show it to you, is that we're just gonna try and estimate confidence intervals around this mean. So in study unit 7, we would have worked out, say, with the Z and all of those things, that this is maybe the sample mean, or this is the mean of proportion. What we're gonna do in this study unit is to say, well, in our sample, that mean can fall between two intervals, a lower interval and an upper interval. So that is basically what we're gonna do in study unit 8. It is, we're gonna work out if that mean is what it is given, or if we calculate it, what is the confidence intervals around that mean. Okay, and the way we were gonna do that, and I will show you some of the definition slides in a few minutes, but how we're gonna do that is very similar to how we worked out previous work. So we need to check if there's a sample mean. We need to check if they give us a population standard deviation or sample standard deviation. So if we talk about the sample mean, how we gonna work out that is we gonna get the mean, as in all of the other questions, and we will need to nearly minus the one part, and we will add that same part to get your lower end and your upper end. And the way we're going to calculate that is, again, with a Z multiplied by the standard error. Okay. So this part, and let me use a different color, this part will nearly give you that answer that you need to add or subtract from your mean. Now that I mentioned standard error, when we look at the proportion, it is very similar. We get the mean, and in this instance, the mean is the P, again, plus or minus, because it is that side or that side. And then what we will need to add again is still a Z. And then from study unit 7, we just need to remember what the standard error was, and the standard error was, if you can remember, divided by n. But again, we'll get to these formulas and you will get it in any case. But this is nearly what we're going to do in study unit 8. Okay, so it's building up from study unit 6, where we only worked out the Z. Then in study unit 7, that Z became that we were talking about samples out of a population. So then that Z became, if it was around the mean, we just added the sample component. And if it was the proportion, now I can't even remember what that formula is, but it was something, let me quickly check. I'll get to that later, but it was, I'm thinking I'm now turning the 2 around. So I will just make sure about that one in a while, but it was something like that. I'm thinking I'm turning those 2 around, but okay. So now we're basically going to the next level where we still have a Z. That Z we will not be likely to calculate. So again, I want to share some tips with you on that. It might be different in your assignments, but in the exam you will have set standards. So in your study guide, there's a table that you can use for all of these calculations in this study unit. So let me just go to that study guide, where I'll also share it on my document that I'm trying to scan again to send to you guys. But I will probably just take a picture again because having problems with my scanner. But let me quickly show you in the study guide where I just want to scroll down to it, and then we can start with the slides. Okay, so this one is going to be very important for you. So let's see if I can. So on page 158. On page 158, this is the table that you will be able to use. And you can write it down, you can make a copy of it. So when you see in the questions, we're talking about a two-tail, and I'll show you how to identify those things. You know, you can work with a Z that is 2.58. They talk about 95, and most of the times we're talking about 95. If it's two-tail, you can work with a 1.96, or but we'll get to that. But this is a table that really is important to keep with you, and that you don't need to work out some of the Z values. Okay, so let's get into the detail. So we're going to, and again for your assignment and exam, you can keep this at hand to see if there's any definitions that you can, if I talk about point estimate, here's just some of the definition that they can ask you around. We go into confidence interval, and And here they also tell you that the ones that you are most likely to get is the 95, the 90, or the 99, which is what we have here as well. It, I want to say it might, because we know the assignments are a bit different. It might be that in an assignment they ask you something else to test that you can get it from the tables, but in a sense very unlikely. Then we go into the confidence of the mean. So here you can see nearly what I've shown you. The important thing is there's going to be two differences when we talk about the confidence interval around the mean. The one that we will get the most is when your population standard deviation is known. Then we follow the perfect process of you have your mean, you get your Z that you nearly remember, you have all the other information. Sometimes they tell us that our population standard deviation is unknown, and then we need to use the t-table. When we get there, I'll show you how to calculate that. So again, what might happen in the exam is you get a question on this, you get a question on this, and you get a question on this. So that you nearly have a question, two questions around the interval of the mean. The one is the population standard deviation is known. The one is the population standard deviation is unknown. To identify between these two, they need to tell you. So it's not that you need to guess it. We'll get through some of these questions that we will be, I'll show you how to identify that. The third one about the proportion is just standard. It is the Z we will be able to get from a table again, and we can work it out accordingly. Okay, so there it was P minus. Okay, so I thought I made a mistake here. I knew something was not right. Okay. Okay, cool. So that is basically on study unit 8. What you need to be able to do is to identify if it is an interval of a mean, if we're working with a population that is known or unknown, or the standard deviation population that is known or unknown. If we're working with a proportion, we just follow the same process. Okay, I'm now talking a lot and about the things, but I think after the recording, it might also be helpful to just go back and listen again. So let's look at the things that we nearly now want to investigate and want to calculate. So very important to read these questions in study unit 8, because it's easy to identify certain things, but there's certain things that we need to make sure that we be able to spot so that we know what to do. Okay, so the statistics practitioner took a random sample of 50. So we have that n equal to 50 from a population with a standard deviation. We've got the sample mean of 100. the 95% confidence interval of population mean. Okay, so the first thing that I nearly also, so they tell us here population with standard deviation. Okay, so if we have that, we know that the population standard deviation is known. If that is known, we use the Z. Okay, so for this one, we use the Z. 95% confidence interval, 95% confidence interval, 1.96. We don't need to go and work out anything. We know that for 95, because we know the standard deviation is known, is 1.96. So if we now go to that formula, just make that plus minus bigger. So if we go to that formula, let's see, we've got the X, we've got the Z, because that is 1.96. We've got the standard deviation, which is 25, and we've got the N of 100. Okay, so the easier ones is when the population standard deviation is known, because then we don't need to nearly calculate the Z. Okay, so now I want to quickly show you some other things that one can nearly identify some of the things that you can nearly cancel out. Okay, so this is the mean is 100. So when we do the confidence interval, 100 is in the middle. So when we're going to subtract the one side and add to the other one, this must be lower than 100 and this must be bigger than 100. Okay, so the lower will be less than 100, the upper will be bigger than 100. So let's quickly go through options. Less 100, bigger 100. Okay, it might be 100 and something very small, not 100 in the middle, yeah, it's 9.31, 10.69, not an option. Less than 100, bigger than 100, possible option. You're very small, 39. So it needs to be in the middle of 100, and there is no ways that this is in the 100. But let's just, because it's smaller and bigger, let's just keep it in the calculation. Okay, then let's work this out. So square root of 100 is 10, so 25 divided by 10 is 2.5. 2.5 times 1.96. Okay, let me just make sure that I have calculated this correctly. Okay, I see I've made a mistake. That should not be, that should be 50. Okay, so I wrote down 100 instead of the 50, and that should teach me as well that I need to, when I do it, also tick off that it is right. Okay, so 50 square root, don't have a clue, so we need to work that out. So that is, I get something like 7.07. So 25 divided by 0.07 is 3,54. 3,54 times times 1.96 is equal to 6.9, and let's just change decimals. 9296. So I need to say 100 plus that and 100 minus that. So my top one will be 106 point. Okay, so I see they have rounded it off. Okay, so let's check the top ones. Only that one will be right. But let's also just do the bottom one. Then we see it is 93,07. Okay, so that is your correct answer. If you look at this, and again, if I do this in your assignment, you probably will get a mark or something, because if you see that answer was that portion. So 200 plus minus that component. So they might I don't always know how they give you, for which things they give you a mark in the assignments instead of a full marks. But this might be giving you a mark to say, well, you knew how to calculate the portion that you needed to add or subtract from your sample mean or your population mean. Okay, so let's stop here first and just see if you guys are happy. We'll go through a few of these, but if there's any specific questions on this, very happy if you ask. Yes, Obaken. Okay. Is there still a question or? Okay, so let's continue to the next one.
Oh, my apology.
Oh, okay.
Can you please, I'm having a problem with these gadgets. Can you please go back to that table where you did select your Z?
This one.
Yes, yeah. To 95%, why did you select 1.96 and not 1.645?
Okay, cool. So when we work confidence interval, we want to calculate. So let me. So chapter 8 is all about confidence interval. So let's say this was the mean. They want us to work out nearly the upper and lower. So with confidence interval, we will always have a two-tail. So there's your one and there's your other one. So we will always have a two-tail with your confidence interval. Where this is going to come and into play with a one-tail is when we move to study unit 9 and when we're going to do hypothesis testing. So at the moment, your confidence interval is basically saying, there's my mean, I want to know what is that and what is that side. So that's why it's a two-tail. When we get to hypothesis testing in one of the next sessions, that's also part of this study unit or this assignment, you will get that you need to say, my mean is maybe equal to 0, and my alternative is smaller than 0 or something like that. And then we're starting with that alternative, we're starting to say, is it a one-tail or a two-tail? And that is when we will need to decide if we use the Z with a one tail or the Z with a two tail. Confidence interval, so study unit 8, we don't need to worry about that yet because it is a confidence interval. There will always be a lower tail and always be an upper tail. So there will always be two tail. Okay, so for study unit 8, we can use these without any worry. Okay, study unit 9, there it becomes the tricky part where we need to decide if it is one tail or two tail. Happy with that, King?
Yes, I'm happy.
Cool. Okay, so let's go into the next. I have created also a bit of the answers for you here, but let's see what they tell us. So from the information below, so they give us that, they give us the N, that already, when they tell us S, needs to give us nearly the idea that we're working with a population standard deviation that is unknown, else they needed to tell us, give us that sign. But let's look in the sentence. Determine the 95% confidence interval of a population mean. Okay, so no mention of population standard deviation. Here we know, going back to, what was it? Study unit 1, where that was population and the S was for the sample. So giving the S, we know this is a sample standard deviation. When it is sample standard deviation, population standard deviation is unknown. When it is unknown, we work with a T. Okay, so when we work with a T, there's nearly two things that we need to remember. So we will need to go to a T table, but how that T table is calculated is a that we will need to get. Oh, what is the DF? Now I'm suddenly blank on what that is called. Degrees of freedom. Suddenly a blank. So we will need to work out the degrees of freedom, and then we will need to work out with the confidence interval. Okay, so that is what we will need to do. The degrees of freedom, how that is calculated, is n minus 1. So on the table, we will need to look for the degrees of freedom that is equal to 100 minus 1, okay, which is 99. Then we will also need to look for the a percentage, so the confidence interval, that 95%. So how we work that out is we will need to say what is for alpha divided by 2. Nowhere in here did they say to us what alpha is. Okay? So what alpha is, and it is in the definitions up earlier, is basically we need to work it out by saying 1 minus whatever the confidence interval is that they've given us. So if they told us it's a 90% confidence interval, we would have said 1 minus 0.9. If they've told us something weird, it's a 80% confidence interval, it will be 1 minus 0.8. Okay, so then that is 0.05 divided by 2, which gives us 0.025. Okay, so we will need to go to the t-table. And the t-table is in a sense, and I'll show you now, you will go down over degrees of freedom, and you will go across for this that we've calculated. So let's just find, I assume it's in study unit 8 at the back. Also, I need to go back to study unit 7. I've got a feeling it's maybe back to study unit 7 with the Z tables, but let's just, yes. Okay, so it's where all the Z tables are as well. So that was study unit 6, actually. Okay. So we had the Z tables. We know we now need to go to the T table. So T table, I said degrees of freedom was, what was it, 99? Sure. Okay, there's 99. We needed to go across to 0.025. 0.025. Oops. Okay, but one above. Let's see. I thought I can just move it. Not allowed to at the moment. Okay, I'll just take out the other one. 1.984. Okay, so in this instance now, where we still can write the Z, so we call it the T now, but then we still multiply it by the standard error. So this one is just the standard error for your sample. N, let's just make sure this time I get it right, is 200 plus minus the 1.984. That you multiply with the S, which is 5, divided by N, which is in this time it's 100. Okay, so before we again even look at how to calculate that with the next step, again, remember top, bottom, 200 in the middle, bottom less than 200, top more than 200. So let's look at options. Less than 200, yes, 20.98. Okay, not an option. less than 200 years, but sure, way back, you remember 200 will be in the middle of, so probably not. Very close, this one, just more than 200, just less than 200 might be an option. 200 and then probably what is in there, not an option. Less than 200, more than 200 can be an option, but again, if 200 is in the middle, it seems like you subtracted 2 on the 1 and added 9, so probably not. So even without calculating that, I'm thinking option 3 is my answer, but let's calculate. So 200 plus minus, so it is 5 divided by the square root of 100. This time it is 10. So 5 divided by 10 is 0.5. We want multiply that by 1.984. We get the 0.992, which was probably in that one that they had it. Okay, so then we know the top one is 200.992 and the bottom one is 199.008. Okay, which is then option 3 is the correct one. Okay, so this was now the one where we don't know what your population standard deviation is. We then calculate, we need to use the t-table. We need to calculate what that t value is going to be, but there's a set way of calculating it. So we need to define what the degrees of freedom is, and we will need to define what that interval is that we're going to work with. So this is how you're going to work out the degrees, your t value. Sorry, it should be there. So again, when your t value, how you work it out, the degrees of freedom is the one that goes down the table, and the confidence is the one that goes across the table. So again, degrees of freedom down, across we see the, it's weird that I couldn't now again draw something with that, but going across. Okay, what and what I nearly want to say, what will happen in your exam and in your study or in your assignment is that you will get an option where you could have used for 1.96. Okay. So one of the options will be that you used 1.96 instead of 1.984. And then it will actually be very close. So it might even have been, if you used 1.96, that your top one was 201.92. But just be, so this is nearly where in your assignments and in your exam, with the sample or the population mean and the sample mean, just be very careful, because here we used 1.96. If you used a t-table for this, it might have been that that was the answer. So just, I think it's very important that from the start you nearly can identify, am I calculating a T or am I calculating the Z? Because just that, and it will not be a big difference if you look at 1.984, 1.96. There's definitely not a big difference between those two. So it will be in decimals nearly that you will get a different answer. But just that is nearly, I think, the most important part of this study unit is to be able from the start to nearly identify, am I working with a T or am I working with a Z? Most of the times it will be the Z. But just that instance, if it is the T. Okay, so let's look at another one. And again, I nearly want us to go through it and first see if we work with a T or a Z. So we're first going to read it, not going to look at any numbers, just read it and identify. So a random sample of 25 was drawn from a normal distribution with a population standard deviation. The sample mean is that the 95% confidence interval estimate of a population mean is. Okay, so what would you guys have said? A Z or a T?
It's it.
Okay, awesome. A Z, because they tell us that we have a population standard deviation. That tells me we're working with a Z. Okay, 95%, so we can automatically then say my Z is 1,96. Okay, let's look at the sample. Sample 80. Okay, if we have sample 80, we do the next one to say, okay, 80 is in the middle. 80 in the middle might be. 80 in the middle might be. 80 in the middle, no ways. 80 in the middle might be. 80 in the middle, no ways. That is interesting. So again, just giving hints, nothing to, but 7804, 7804, 8196, 8196. I'm like, okay, I know it's not that one. If I'm in the exam, I've got 5 minutes to go through questions. That would have been my answer, just because of that. By fluke. So if there's, I think there was in one of these, there was also something weird. But we'll check it if I see. Yeah, I see. So this one, if you just look at it, 9339. So it's nearly, if you read it just quickly, and so there is sometimes other indicators in it that might hint you to options. Okay, so if I had 1 minute left in the exam, I would have said, okay, I would have gone very nearly first and said, okay, let's see. Okay, there's 3 that I can guess. That one looks very similar to that one. Can't be that one, so I would have just guessed that one. But let's do all the other things. We've got the standard deviation of 5, and we've got our what do we need? N is your sample of 25. Okay, so we've got 80 plus minus 1,96, and then times the standard deviation, which is 5 divided by 25. Square root of 25 is 5, so it is actually 80 plus minus 1.96. Okay, so look there, 80 plus minus 1.96. So your top one is 80 point, um, 81.96. We go through. And then your bottom one is 78.04. Okay, which was in option one. Okay, so how I would do it, identify T or Z, then 95 confidence is 1.96. We have all the other values. I would then nearly use this to say, is there anything that I can cancel out? Just to give me a better option of when it comes to the last 2 or 3 answers, what to expect or what to get. Okay. Let's see if we move over to population. Not yet. Okay, so again, I think the last 2 is on population proportions. Okay, so let's just read through it and then see what to do. Simple random sample of 30 has been collected from a population for which it is known that the population standard deviation is that. The sample mean has been calculated for 95 confidence for the population mean. Okay, again, Z or T? What would you guys say? Okay, so the population standard deviation is known. So we're working with a Z. 95%, so we know that Z is equal to 1.96. Let's see what's the mean, 240. Okay, 240 in the middle can be that, so that is probably going to be what we need to get, that we're going to subtract and add, but I guess that one is wrong. 240 in the middle can be 240 in the middle can be, okay, look at that one, turned around, so it can't be, so no. So now if you look at this, you're very close. 5784, 7336, 7558, 236.42, 0.26, 0.24. Okay, so this is really very close numbers that we need to calculate. Yeah, so I'm wondering why it is like this. It might be, let me just, so if we set degrees of freedom, let me just check if we have gone with 29. Okay, no. So, okay, so let's do it. So it's 240 plus minus Z times what is the standard deviation is 10 divided by the sample of 30. I really don't hope now it is in if one rounds off that answer, because then it will be not very great. So the square root of 30 is 5,4772. If you say 10 divided by 5,4772, you get 1,8257. Okay, and if you multiply that by 1,96, we get plus minus 3,578.5. Okay, so it is actually that one. Okay, so the 240 plus 3,57, I'll do the top one always first. It's just easier. 5785. So let's see, 5785. Okay, so there is our final answer. Let's just subtract. So we get 236.4215. Okay, so there is the answer to this one. So again, first identify T or Z, then we can work with the confidence interval. We know it's 95, so we can say 1,96, and then we just follow and work through. Okay. So the last two is on proportion, and proportion again, they tell you. So there's nothing they need to tell you we're working with a proportion. So there's nothing here that can be seen as something else. They need to tell you you're working with a proportion. Okay, so let's look at what they tell us. A random sample of 80 observations. So we've got that at least results in 50 successes. Okay, so 50 successes. 50 divided by 80, because that is the proportion of successes. Confidence interval of 95, so we can again work with a Z of 1,96. Okay, so let's look at what is that 50 divided by 80. It's 0,625. 0,625. So the same principle, 0,625. The upper limit will be higher, lower limit less, and the 0,625 needs to be in the middle. Okay, so that is probably going to be the part that we have here. But it needs to be, okay, so not that one, 0,65 less and higher, that can work. 0,625, that can work. 0,625, that one can work. And no, because 0,625 can't fit into that. Okay, so if you needed to guess, there was 3 options that we needed to guess out of. So, but let's work this out. 1,96 times, okay, 0,625. 1 minus 0,625 is 0,375. We're going to multiply by that. Just need to get n right this time. N is 80. Okay, so 0,365 times 0,625 divided by 80. Okay, so let me just write that one down first. 0,0029. And then if I square root that, we get 0,0541. If I multiply that by 1,96, we get this. We get 0,1061. Okay, it was very close to that. Rounded off, it would be 0,106. So that then tells me that the top one is 0,731 and the bottom one is 0,519, which gives us option 4. Okay. So this instance, because it's population proportion, we can work with a Z. Very similar then to the where we know where the population mean is known. The 95% is 1,96, and we just follow nearly the formula that we can use. Okay, and again, the formula is available. It's open book. You don't need to memorize it. Yeah. Okay, so let's go to the last one and finish this off. So again, population proportion. So let's see what, according to statistics reported on Stats SA, a surprising number of motor vehicles are not covered in insurance. The results consistent with the Stats SA report showed 46 out of 200 vehicles are not covered by insurance. Okay, so that is your P. Okay, there at least, sorry, I misread that. Okay, so 46 divided by 200 is 0,23. 0,23. Okay, so 0,23 in the middle. 0,23 in the middle can't be 0,23 in the middle. That can be 0,23 in the middle, not at the lower end, can't be 0,23 in the middle, so that needs to be smaller, that needs to be bigger, can't be 0,23. Okay, so it's between 1 and 5. Okay, so let's then do the rest. 0,23 plus minus, we know Z is 1,96 because of the 95% confidence interval. Zero comma 0,23, what is it, times 0,77 divided by n, which is 200. The 0.23 times 0.77 divided by 200 is 0,0009, so it's 3 zeros. But we still need to take the square root of it. 0,029. 8. Need to multiply that by 1.96, which is 0.0583. I hope I now calculated that correct. So that plus 0.23 is equal to the top one is 0.288. See, now I've got 2883, so it's very close. And 0.1717. Okay, so it's very close to that one. So there is your option. I must just check. I probably rounded off too early already in my answer. Okay, so again, population proportion, I need to tell you the Z, because it's 95, one can say it's 1,96. And then we have a formula and we just substitute what is in the formula. Okay, so that's study unit 8. So it's basically study unit 8, you need to be able to do 3 things. It's work out the confidence interval when your population standard deviation is known, then we use the Z. When your population standard deviation is unknown, we use the T. And if your population proportion is the question, we use the Z. And that's the 3 things that out of this study unit you need to know. Confidence interval, always two-tail. So it's not there anymore, but always two-tail. So you can use the 1,96, the one for 90, and the one for 99, always two-tail. When we go into hypothesis testing, that is where it becomes tricky and we need to identify one or two-tail. But that's for next week. Questions, anyone? I know we went through this very quickly actually this week, but any questions? I think we probably will also include nearly a round-up catch-up session on both study units 8 and 9. I'll make a PDF of this again to send to you. I'll take photographs of my own notes as well. I'll send that to you today as well, and then this recording will also be on WhatsApp again a bit later. But any questions from your side? Okay, cool. Happiness from Elizabeth. Anyone else happy? Any other questions? Else, it is it for today. Okay, cool. Thanks, guys. Then have a great. Oh, Ken, do you want to ask something?
No.
Okay,
I
cool.
was just gonna say thank you.